Hello, hello, hello everybody, and welcome back. In this video, we are taking a look at question number 22 from our 2019 Fermat paper. In the diagram, two circles touch at P. Also, QP and SU are perpendicular diameters of the larger circle, and they intersect at O. Point V is on QP, and VP is a diameter of the small circle. Okay. The small circle intersects SU at T, as shown. Okay. We're not really told about this other point down here. If we wanted to, we could name it probably W or R or something like that. But I won't do that until I feel like we need to. But we got T there. We know that QV is 9 and ST is 5. And we want to know what is the sum of the lengths of the diameters of the two circles. So we might not actually be able to work out the individual diameters, but maybe there's some way to find out the lengths, or the sum of the lengths. Okay, so that's going to be our challenge here. So let's draw this picture and see what we can see. Draw our big circle. Draw our small circle. That's actually not bad for intersecting circles there. That we can do a little bit better. As I'm always quick to say when my diagrams don't go well, as long as the picture is clear to you, that's fine. Remember, it's a multiple choice contest. Nobody's gonna be marking you on your rough work. You don't even hand in your rough work. All right, so we got a 9 here. We got a 5 here. Now, we're talking about diameters, but I'm more comfortable with circles when we talk about their radii. So, for example, the radii of the big circle, well, O is the intersection of the two diameters, so it's got to be the center of the circle. If I were to call the radii of the big circle capital R, here are some lengths that are capital R. OP is capital R, that sort of a thing. Okay. But what else could we do? Well, we could talk about little r, maybe make that the radius of the small circle. Now, I don't know where the center for the small circle is. I'm going to put it here and call it C. But I'm going to say it's got a radius of little r. And so PV, that's a diameter of the small circle. So PV should be 2 little r's. Okay? What else can we see? Well, two of the big R's is QP. That's a diameter of the big circle. It's two of the capital R's, but that's also QV plus VP, and so that would be 9 plus 2 of the little r's. So that's kind of an interesting relationship. But what else can we do? We haven't used T at all here. So what I'm going to do is I'm going to connect T up to the center C there. And if you'll notice, what we've got here is a nice little right-angled triangle. But what are the sides of this triangle going to be? Well, the hypotenuse is CT. That's the little r radius. And then what's left over here, T to O? Well, S to O would be capital R, but we come back a distance of 5, so this is R minus 5, capital R minus 5. And then what have we got down here? Well, we've got OP is capital R, but then you come back by a distance little r. So we get R minus little r. So I have a nice relationship there, and that is related by the Pythagorean triangle, or the Pythagorean theorem. So I suspect we'll probably use this relationship. 2r is 9 plus 2 little r, and then some relationship involving this triangle. So let's move to another page. I'm going to rearrange this so it says 2r minus 2 little r is 9. Okay? And then using my triangle, I can see r squared is capital R minus 5 squared plus capital R minus little r squared. So you expand that out. We get capital R squared minus 5, minus 10R plus 25, and then capital R squared again minus 2 little r capital R plus r squared. Those will cancel out. So we'll have 0 is 2r squared minus 2r plus 10 capital R plus 25. Okay. I wanted to divide by 2 on both sides, but with that 25 there, I'm not exactly thrilled with this. Now, ultimately, what do we want? We want to know, well, we want to know the sums of the lengths of the diameters, right? So we would need to know 2 little r plus 2 capital R. That's what we'd like. But what can we really learn from this quadratic relationship? Should we even be going down this route? Because I don't see something immediate I should be doing here. Can we do some sort of difference of squares? Not that I can particularly see. It's quadratic in terms of r. So let's see where that goes. Negative b plus or minus. This feels a little too complicated, though. I mean, it's a Fermat question. It's a Part C Fermat question, but it's also, question 22. I feel like I'm missing something. We have 40r plus 100 minus 200 all over 4. Okay. That definitely doesn't look good. Let's go back to the pictures. Is there something else we might be able to do here? Let's see. This. What about this length? Is there another way to get the bottom side that might be a little nicer to work with? So this length here is r minus 9. So this length here would be little r minus r minus 9. Right? Yeah. Oh, you know what? I guess we could do. Yeah, just divide by 2 over here, and I've got r and little r. There we go. Okay, so I can get rid of all this quadratic stuff. I should have solved for the relationship between r and little r sooner. Okay, so this is actually r squared is capital R minus 5 squared plus 9 over 2 squared. Maybe this will be a little nicer. Although it doesn't get rid of the r here, so, well, we'll see. Okay, so r squared minus 10r plus 25 plus 81 over 4. Okay. Where to go from here? I honestly don't know. Again. So I guess what we could do, we could bring this R over here. Yeah. Oh, that might work out quite nice. The 10R here makes me unhappy. Unless... Instead, I'm going to rearrange my expression. Because this is now a difference of squares here. So I can call this r minus 5. And then call this r plus r minus 5. And there I'm getting r plus r, which is great. Now over here, this simplifies to r minus capital R plus 5. But that's negative 9 halves. So this whole thing here should just be 1 half. So 1 half r plus capital R minus 5 is 81 over 4. So multiply both sides by 2, and we'll get r plus 5, or r plus capital R minus 5 is 81 halves. Now if I add 5 to both sides, 5 is 10 halves, so I'll get r plus r is 91 halves. And we don't want the sum of the lengths of the radii, we want the sum of the lengths of the diameters, so we double this. And we get 91. There we go. Okay. So a little bit of trouble seeing exactly the right way to proceed. I got the triangle pretty quickly, but I didn't use this information as quickly as I probably could have. But there we go. We get 91 there, and that's an answer of B. So I'll finish off question number 22 for us. We'll get a fresh sheet of paper for question number 23 coming up next time.